Question 13 is, I'm trying to do a correlation matrix, but there seems to be like there's variables on by column and row. So my correlation matrix never works out right.
Okay, share your screen and let's work through that.
Okay.
And of course, you guys are free to go if you need to.
So this is the raw data.
Okay.
I just don't know how to highlight it to get the right correlation matrix, because every time I try something, I get a different matrix.
Okay. And you're going to data analysis.
Mhm.
And then which one are you?
Correlation.
Correlation. Okay. And so the way you're setting it up, let me see. That and every other value. I think it would be a good idea to put it all into one column. So you'll have, well, hold on a second. So accuracy, 2011, 2010. Okay. Accuracy. Actually, try highlighting it without the dates.
Okay.
That might be throwing it off. Okay.
And so then it would be grouped by rows, right?
Group by rows. Yes.
And we can put it over here.
Okay. Input range contains non-numeric data. Group by rows. Oh, okay. That might be your issue. So group by rows, and then so you grouped it by rows, but then you said label in the first column. So it's reading the labels as what should be numbers. So you have to rearrange the data. So press cancel.
Okay.
And let's rearrange it to where you're grouping by column, and then you say column in the first section. So wait, before you do that, can you go back?
Mm-hmm.
And delete what you just did a second ago? Okay, highlight just the labels and the data.
Why is it doing that?
Press escape.
Okay, there it is.
Okay. Oh, that's weird.
Oh, something's hiding there. That's why.
Oh. Okay, that might be the part of the issue.
Did I do that? Maybe I'll just go back to the actual data, like the actual Excel file.
Okay. So it provides 5-year data, identifying, find the correlation matrix, and propose. Okay.
Oh yeah, that's how it looks. It has that.
Okay. Well, there's a fix for it. Just highlight the numbers right there, and then Control C or copy. And then when you paste it, you want to paste special, and you want to transpose it so that it turns into columns.
All
So
right.
paste it wherever you want to paste it. I don't know.
Just right here. Paste special.
Transpose. Yep.
Ooh.
Okay. And then you're going to do the same thing with the labels. You're going to transpose those so that they correlate with each one.
Should I highlight the X part or just this part?
No, just the labels.
Okay.
Cool. All right. So now when you do your correlation, you can tell it that the columns have the labels, and then you can group by columns. So it'll make it easy to read.
All right.
That should be accurate.
Yes, okay, great. Thank you.
No problem. Are you good on the like explanation with the cause and effect and correlation and all that? Okay.
Yes.
Can you explain? I'm not good.
Do you actually want to explain it?
Sure. Let me see
Amira?
if I wrote it down. Well, the first part is like doing the leading and lagging measures. So I did that. And then whenever I do a correlation matrix, or the textbook kind of says to like highlight some of the highest correlations and some of the lowest ones. And then what does the question say? And then propose a cause and effect model. I do need help with that part too.
Okay. So the textbook is like a little vague about like how to do it,
Yeah.
but even if you like read it all the way through, it's still kind of like so. Can you share your screen again?
Sure can. Should I share the textbook or just this part?
Just that part is good. All right. All right, so the question is identify leading and lagging measures, find correlation matrix, and propose a cause and effect model using the strongest correlations. Okay. Now, it looks like the leading and lagging measures what happen and are often external business results. So you kind of have to use your knowledge of business. It's not really a mathematical thing. So the lagging measures are measures that it says it tells what has happened and are often external business results. And then leading measures are things that happen internally and they're like performance drivers. So order accuracy, I would say that's a performance driver. Timeliness of delivery, table cleanliness, well, all of those seem like performance drivers. Market share seems like a lagging measure because it's an outcome. Let me see, revenue per employee, that is an outcome. So you can say that it's a lagging measure. So I'm just going through some of them, giving examples. So order accuracy, things that the company can control are leading measures. Things that are a result of the company's actions are going to be the lagging measures. Okay, so that's the first part. And then find your correlation matrix. We just went through that. And then the cause and effect model, I would say for that one, just take maybe 3, 4, or 5 of the largest numbers you see there, and then say that the values that go with those numbers have the highest correlation with one another. And then you can start thinking about what that means for a business. So when you have a higher correlation, it's going to be closer to either 1 or -1. If it's 1, then it's a strong positive correlation, meaning they move up together. If it's -1, it's going to be if one increases, the other one decreases, and that's a strong relationship. If your correlation is close to 0, there's almost no relationship between the two. Okay, and then let's do a quick example. So one of the larger correlations, let's say timeliness of delivery and hourly employee satisfaction. Oh, well, either one of those could work. But this makes sense in context. It's saying that as the timeliness of deliveries increase, which is a leading measure, so something that the company can control, as that increases, the employee satisfaction also increases, which is an outcome or lagging measure. Right. So it's easy to see that if there's a strong relationship, the leading measure can affect the lagging measure to a high degree. Make sense?
Yep.
Cool.
Thank you.
The textbook also showed kind of like a visual for the model. Do we have to try to create that, or we can just explain it? It had like a diagram almost.
I see it. It's okay, it's 10.18 satisfaction with supervisor, job satisfaction. I mean, I don't think it would hurt to try to create it. Let's see. So satisfaction with supervisor, job satisfaction, training leads to, okay. So it's kind of like building the mental model of these company-based factors lead to 1, 2, 3 outcomes, which also lead to 1, 2, 3 outcomes.
Right.
So you use the strongest correlations to say that this value leads to these other values. Yeah. And so we see that with it's saying job satisfaction leads to employee satisfaction, which leads to customer satisfaction. And if all 3 of those have a pretty high correlation, then that would be backed up by your matrix.
Okay.
So you can try to create it. I don't think it'd be too hard.
Okay.
And it does say, yeah, it does propose a cause and effect model using the strongest correlations. So yeah, just use words to show it if you want. All right. Do you guys have any more questions? Is everyone good on the earlier questions, like the college question, credit approval, decisions, dendrograms? Everyone good
Could you
with that?
explain the standard deviation again? Because I kind of forgot what you said, like just the analysis, like the higher the standard deviation or something. I can't remember.
Oh.
Is the errors.
Yeah, so in that analysis, don't get too heavy with the standard deviation. The mean is more important, but the standard deviation tells you how much error is in your like in your data set. Because so think of it as the variance, right? How much does your data vary from the mean? If you have a higher standard deviation, there's a higher variance from the mean. So your data is more spread out. So if you try to say that the average test score is 80%, but your data is really spread out, that means that there's a lot of error in your statement, because you could get a lot of data points that are well above 80 or well below 80 because the data is so spread out. So higher standard deviation means higher error.
Okay, and then the mean was just like if the college students are, let's say the SAT score, like if the average of that column is higher than the total average of the whole data set, it means that the students performed above average in their SATs.
Yep, in general, among those two schools in that cluster. Yes.
Okay. All right.
How do you feel about the discriminate analysis? Number 9. We're good with that one? Because I know some people were having trouble with that. Okay. So this is the data set that's in the question. And they're asking, classify these new records in the Excel file using only credit score and years of credit history as input variables. Okay, so it looks like it's already done it for you with all the other ones. You just need to do the same thing using credit score and years of credit history only. So, and here's your records to classify. So I'm gonna put everything into a new Excel file or a new sheet so that we can just work with the raw data for now. So sheet 1. All right. And then this is the raw data. Next to it, I'm just going to put years of credit history and credit score. Control C, Control B, and then of course the decision. So these are the only things we're going to build our model on, according to the question. So first step for discriminant analysis is to run a regression. And we see that was done here. And like you guys said, he does run a regression he does run a discriminant analysis in class using Excel, but the textbook is telling you to use regression to do it so that you better understand the question. So we'll do it the way the textbook does it, and then maybe try to confirm using the data mining tool. But this is how it's done in Excel using the regression. So data analysis. We're going to run regression. So your Y range is what you're trying to predict. So that's the decision. X range are going to be your predictors. So I got those here. We have labels. And let's put the output range right here. Okay. We don't really need all of this extra stuff, so I'm just going to leave that unchecked. All right. So here we are with that. And for each record, we need to give it a discriminate score based on the regression line that's here. So this line represents the line of best fit for this data set. So let's say we plotted every single data point on a plot, scatter plot, right? And the blue ones are decision 1, so high credit risk, or the red ones are high credit risk, the black ones are low credit risk. What the discriminate score is doing, or the regression line, is creating a line of best fit, right? So this is our line, and it's denoted by this formula here. So the intercept, and these are your Y values, right? And then the cutoff is going to be this line right here. And let's say it is 0.49, like we have here. So about half of the Y. So with your discriminate analysis, if you have a new point and you plot it on this line, so say you plot it right here on this line, you can say that because it's above your cutoff score, it is likely high risk. If you plot a point on this part of the line, it's below your cutoff score, so now it's low credit risk. So that's the whole concept of a discriminate analysis. You run your regression to find the line of best fit. Then the discriminant score is going to tell you where that point is on the line of best fit. And once you plot it on there, if it's above the cutoff, it's high credit risk. If it's below the cutoff, it's low credit risk. So that's the math behind it. And so I'm going to find a discriminant score. Okay. And similar to the original data set, the discriminant score, it looks a little complicated, but it is the intercept times the coefficient times every single value. So basically you're plugging in the values into the line. So equals to the intercept plus the credit score coefficient times the credit score value plus the years of credit history coefficient times the years of credit history. And I'll put parentheses around each one, even though you don't really need it because order of operations is going to multiply first anyway. But that is you plugging in these values into the formula. Let me zoom in because I know it's kind of hard to see. So you're plugging these values into this formula, which is essentially plotting this person's credit history and credit score onto your line of best fit. That's essentially what you're doing. All right. There's no need, well, actually there is a need. You do need to lock, if you're gonna bring it all the way down, you need to lock the things that need to stay in place. So you're gonna lock the intercept. You're gonna lock the coefficients. And then now you can apply it to the entire column. And let's just check. This is good. It's locked it in place. All right. So now the question is asking, classify the new records using only credit score and years of credit history. So now let's go to our new records. which are these. And just based on years of credit history and revolving balance, we need to give these a discriminant score also. So we're going to use the same formula. Score. And again, when we're finding the discriminant score, we're plotting it on the line of best fit. So equals to intercept plus coefficient times credit history plus, I copied that wrong. Hold on. Let me get the right ones. It's credit score. Control V. Okay. Intercept plus credit score times credit score plus credit history times credit history. All right. So now we have the discriminant score, and we've plotted each one of these new records onto our line of best fit. And now our cutoff is this value here. So that is the same thing as this line right here. So we have to see if our values are above or below the cutoff score. So I'm going to do an if statement, above or below cutoff, question mark. Now you guys can label it whatever you want, just whatever you see fit. But I'm going to do if this value is above the cutoff value, then say above. And otherwise, say below. Okay, so now for each one of these new records, we found out if it's above or below the cutoff score. And I just want to, and I need to lock these. That's why that was 0. Yep. Okay. So you guys should have the same numbers as me now, since I locked it. And double check. Yep. All right. Do you guys have any questions so far about the concept or what I just did?
Where did you get the cutoff value? I think I missed that.
So that was already in the worksheet.
Okay, cool.
Yep.
All right.
And now one more thing, I just want to translate this to high or low credit risk. And let me see what the code is for that. Hold on a second. Okay. Discriminant score, decision. Okay, so it looks like the values that are above 0.49 is going to be high. Wait, trying to see what this translates to. For credit approval decisions. Okay. So it's actually approve or not approve. Okay. So everything above the line you approve, everything below the line you do not approve. So we're not talking about credit risk, we're talking about approve or not approve. So again, we can do an if statement. If above, then you say approve. And if not, you reject. Let me zoom in so you can see that. Okay. So again, I did a if statement. If this is above then you approve it. If not, then you reject it. So if it's above the cutoff score, you approve. If it's below the cutoff score, you reject. So decision. And sorry, guys, I got mixed up with the credit risk and the approval decline data sets. But this one is approve and reject. So, all right. Did I confuse you guys, or did that make sense?
It makes sense.
Made sense? Okay, cool. Any questions about the concept of discriminant score or discriminant analysis? No. All right. I think we can call it in for today. If you guys are pretty much done.
Thank you, Ruth.
All right. I wish you guys luck
Sorry.
finishing your assignments. What'd you say, BC?
For number 10, should we use the method you used in number 9?
Let me see. Extract the records for business for credit risk, code the non-numeric data. Yes. Yeah. Use the same method.
Okay.
All right. And
Thank you.
after all of this, like focus on the story part, because you know how much he emphasizes in class. He wants to see a story. So like really focus on the analysis and story part. Okay. All right. Have a good night, you guys.
Thanks so much.
No problem. Bye.